Advanced port scan detection. Advanced port scan detection is considered as an initial stage of an attack vector or always begins with an port or a network scan. Many adversaries keeps on targeting multiple publicly available servers to gather or enumerate sensitive information like open ports, services, IP address, etc. Our ultimate mission is to understand the entire working of various advanced port scan used by many adversaries. Port scans and commonly used techniques for information gathering on the targeted servers or in host, which will result back with open ports and services. The result can be used for further exploitation. Port scans are classified based on the techniques and functions. The majorly used advanced port scans are vanilla port scan, strobe port scan, fragmented packets, UDP port scan, sweep port scan, FTP bounce, stealth port scan. Vanilla port scan is considered as one of the most commonly used port scan techniques. The major outcome of vanilla port scan results will display all available open ports at the targeted network. It generally uses three-way handshake techniques, TCP, on the targeted system to determining the open ports. Strobe port scan are a bit similar to vanilla port scan. It also basically uses TCP protocol. It will generate and send an TCP SYN packet to a target host on a specific port. It will wait for the response. If the host responded with an acknowledgement packet, then the port is considered open. If the host responds with a RST packet, then the port is considered closed. It's generally used for large-scale or infrastructure scan, and it has been embedded with many vulnerability scanners too. Fragmented packets. It is considered as a bit of unique port scan techniques. It's mostly used in case of firewall and IDS evasion techniques. In a fragmented packet scan, the scanner sends multiple smaller chunks of packets to the target host, each with its own IP header and fragment offset field. These packets are designed to reassemble into a complete packet when they reach the target host, but they may be blocked or dropped by intermediate devices if they are not configured to handle fragmentation properly. It typically waits for the response. If a successful response received, it will considered as an open port. UDP port scan, a new way of determining open and closed ports. It typically send in user datagram packets to a range of ports on the targeted host. It uses ICMP services to determine its availability. If the host responds with a destination unreachable message, indicating that the port is open and accepting UDP packets. If a port is closed, the target host will typically not respond, indicating that the port is closed or filtered. Sweep port scan. Its combinations of TCP and UDP scan. The scanner typically sends a huge packet to a range of consecutive ports, starting from a low port number and increasing to a high port number. It will wait for the response from the target host for each port. Sweep scan been easily detected by firewalls or intrusion detection systems. FTP bounce, and another unique type of port scan technique where the scanner takes advantage of a feature of FTP known as FTP bounce or FTP proxy, which allows an attacker to use a vulnerable FTP server as a proxy to scan another host. This specific techniques generally targets an publicly accessible FTP server to act as an intermediate for request and response from the scanners. When the scan gets initiated, the request will be sent to a publicly accessible FTP server, and the FTP server sends a port command to the targeted server, which includes the IP address and port number of the target host. Stealth port scan is a port scan evasion technique used by the attacks to evade firewall and IDP. It basically uses an old-school techniques of TCP scan. Encrypted TCP request has been sent to a targeted host, which also termed as half-open scan or a SYN scan. The scanner sends a TCP SYN packet to a target host on a specific port, but does not wait for a response. If the port is open, the target host will respond with a SYN-ACK packet, indicating that the port is open and accepting connections. If the port is closed, the target host will respond with a RST packet, indicating that the port is closed. The scanner can then infer the status of the port based on the absence or presence of the SYN-ACK or RST packet. This technique can be easily evaded from firewall and IDS detection, but it can be easily detected by advanced/next-gen firewall and IDS.